Welcome to the OSI model.
The application layer is an abstraction layer reserved for communication protocols and method design for process-to-process communications. It's defined by the OSI model as being the user interface. Some examples of TCP/IP protocols used are FTP, SMTP, POP, IMAP, and DNS. The presentation layer serves as the data translator for the network. This layer is sometimes called the syntax layer. The sublayers are listed below. The session layer provides a mechanism for opening, closing, and managing a session between end-user application processes. Communication sessions consist of requests and responses that occur between applications. Session layer services are commonly used in application environments that make use of remote procedure calls. Some examples of protocols that are used are PAP, PPTP, and SDP.
The transport layer. The transport layer is the fourth layer in the OSI model. It provides transparent transfer of data between end systems using the services of the network layer and example IP address below to move PDUs of data between the two communicating systems. Protocols supported are TCP, UDP, SPX, and also multiplexing. It breaks data into segments, handles sequencing and acknowledgements. The data communicated by the transport layer is encapsulated in a transport layer PDU as segments. It also ensures reliable arrival of messages and provides error checking mechanisms and data flow controls. The flow control will allow the transport protocol entity and the host to restrict the flow of data over a logical connection from the network protocol entity and into another host. The network layer. The network layer is the third layer in the OSI model. This layer provides switching and routing technologies, creating logical paths known as virtual circuits for transmitting data from node to node. Routing and forwarding are functions of this layer, as well as addressing, internet working, error handling, congestion control, and packet sequencing. Protocols supported at this level is IP, IPX, ICMP, and routers operate at this layer. Network layer knows the address of the neighboring nodes in the network, packages output with the correct network address information, selects routes of best quality and service, and recognizes and forwards to the transport layer's incoming messages for local host domains. When data arrives at the network layer, the source and the destination address contained inside each frame are then examined to determine if the data has reached its final destination, and the PDU at this layer is a packet.
The data link layer, layer 2 of the OSI model. This layer works with frames and defines how computers access the network medium, media access control. At this stage, the PDU is called a frame and adds the frame check sequence, which contains the CRC and also adds the MAC address. The software operating at this layer is the NIC driver, and the hardware includes NICs and switches. Problems occurring in this layer include collisions and invalid frames, which can be caused by poor network design, line noise, or NIC driver problems. An additional error is incompatible network technologies. The physical layer, layer 1 of the OSI model. The job of the physical layer is to convert bits into signals for outgoing messages and signals into bits for incoming messages. Details for creating a physical network connection are specified. This layer also specifies how to encode bits. Network components operating at this level include all the cables and connectors used, plus repeaters and hubs. Problems occurring in this layer are often related to incorrect media termination, EMI, and NICs and hubs that are misconfigured or not properly functioning.
Produced by Blaine, Chris, Tyler, Sal, Jeremy. Thank you for watching the OSI model.